everyone, my name is Abhishek Jain, and through this video I am starting a new tutorial series on a very interesting topic which is related to the large language model. We know that process is fine tuning, and everybody nowadays talk about the fine tuning of a large language model. And that seems to be a complicated topic, but in my opinion, it's really challenging and the interesting topic one should understand whenever they are going to just understand the artificial intelligence tools progress, which is happening almost on a daily basis at very fast pace. What I did is I tried to just create a very simple 7-part tutorial series where I will be covering not only the functional aspect, but how you can fine tune a very simple small model so that you can understand all the nitty-gritty of fine tuning, and then you can use that knowledge to build a very powerful tool by fine tuning the existing large language model. So in the very first part, which is this one, I'm going to just cover the functional aspect, like what is fine tuning, when to use it and why, when not to use it. And I'm going to compare the fine tuning approach with RAG and prompt, when we need to use fine tuning or RAG or prompt or the combination of all of these three. And then we're going to talk about the key takeaways in today's video. The second part is I'm just going to deep dive into the fine tuning code concept, because that is really important, because when you are going to do the fine tuning of large language model, you have to just play with a lot of configurations. And if you want to change those configurations, then you have to understand those code concepts. The third part, we are going to use a Google Colab so that we don't have to worry about any infrastructure related nitty-gritty, because Google is going to provide us a GPU and TPU through which we can easily fine-tune that, right? And then the next part, which is fourth, we are going to understand the data set which we are going to use and the model which we are going to fine-tune with the PEFT configuration, which stands for parameter efficient fine-tuning, which actually help us to not only reduce the computational resources, but it requires a very less storage to fine-tune the large language model. The next one is where we are going to understand how we can just load the model, the pre-trained model, and how we can just train with the data set which we are going to finalize. Once the training is done, then we are going to evaluate and we are going to understand the concept around how we can use those fine-tuned model and figure it out whether the accuracy or whatever specific need because of which we are doing a fine-tune is happening accurately or not. And then we are going to just doing a working demo of the fine-tuned model with the real-time use case. So these are the 5 different parts in which we are going to cover this tutorial series. So let's start with the very part 1. So what is fine-tuning? How does fine-tuning achieve a desired behavior? And what real-time analogy can be used to understand this easily in a simple words? So what is fine-tuning? We know that large language models are already pre-trained on a very large data set, and it's very intelligent to respond us for any subject, right? And we already know that because we all are start using it. But fine tuning is something where, these trained large language model are not having any information during the training, because there can be a lot of situations. For example, the legal, documents, industry specific, customer information or the domain specific information, especially in the healthcare, where, those information is not publicly available, where, these big organizations which actually release these large language model, they can train that, right? And there can be n number of situations, because we have a lot of industries which doesn't expose their data, and we need a very specific task to be done by using these large language model. At that point of time, we have to just train these large language models so that the domain specific nitty-gritty or the specifics can be understood by those large language model, so that it can start answering a specific questions related to the specific domain and the industry. So that is where we have to do the fine tuning. Okay. Now, How does fine tuning achieve desired behavior? What I just explained. Instead of training from the scratch in fine tuning, what we do, we actually try to just train, the models with a supervised learning process where we actually not change all the variables in the large language model, but we try to just change the weights. We're going to understand what exactly the weights, in the next video, where I'm going to just cover all the core concept you have to understand. But you need to understand when large language model actually gets trained. So they have biases, they have weights, they have loss functions, they have a lot of other things which actually gets adjusted. But in fine tuning, we are just going to adjust the specific weights through which large language model will be able to answer a specific question related to the specific domain. Now, the next thing is, what is the best and the simpler analogy through which we can understand this fine tuning? So, as you can see on my screen, imagine a doctor who knows general medicine very well. So, fine tuning is like giving that doctor a specialized training in the cardiology. They still retain their general medical knowledge, but they also get the knowledge about, the heart condition, whatever probable data which we have collected for the heart related diseases, the cure around that, the medicine and all those kind of stuff. If we somehow give that entire information to the doctor who is general physician, then he can understand that heart as well. The same thing, we are going to do with this specific new data set which we're gonna create specific to the domain, and then we will take a pre-trained large language model and we will just train with that newly domain specific data, which is going to be most of the time the supervised learning, where we know, okay, this is what our push, this is what our input or request, this is what our response is gonna be. So we have to spend a lot of time in building that kind of data set, and that is the part is the most important, most time consuming task, where we have to build the data set to fine tune the pre-trained large language model. Now, just a very high level flow, what we have to do in fine tuning, right? So the very first thing, we have to identify the use case. So we have to define what exactly we want to achieve, where the large language model is not helping us in a significant way with the accuracy, right? So we are going to define that what precisely we need. Once we have that objective or the use case for which we want to do a fine tuning, then we have to collect and prepare the data around that use cases as much as data possible, right? And then we have to decide, okay, which base pre-trained model we need to use. So there are there are so many large language model available on Ulama, Hugging Face. There are many more repository nowadays where you can just find the models and the information, like, where precisely they have a more intelligence, right? And based on that, you can decide. Once we have that base model design, then we do a pre-processing of data through which, we can, because the data which we are going to provide, which we prepare, we cannot directly fed to the base model. So we have to use some models to change that data which we have collected into a specific format through which the large language model can be fine-tuned. Right? So we fine-tune the model, the pre-processed data, then we evaluate the performance. And once we have a satisfactory performance and we are comfortable with the outcome, then we deploy a fine-tune and we monitor it. This process actually gets straight until or unless we are satisfied that what we precisely want from the fine-tuning is being achieved or not. Okay, so this is what we have covered so far from the basic functional aspect of fine-tuning. Right? Now we need to understand, why do we need a fine tuning? On the very high level, we have already covered that, right? But just to reiterate, base model doesn't perform well on a domain specific task. We have already talked about it. Need a consistent behavior or tone, because what happens if you just send a one request to the large language model, and after that, if you send the same request to the large language model, you will find the response will be different, right? And that is where the fine tuning will be very, very helpful, and we're going to see how we can achieve that. we have to reduce the hallucination in the fixed domain. So what happens whenever you ask any question to the large language model, it always responds, whether it knows about that topic or not, it will always going to give you the response, right? And that is where, the RAG and this fine tuning help us to reduce the hallucination, which large language models normally has for the unknown subject or a topic or a request. Application has a low latency or offline requirement where retrieval is not feasible, right? So this is the another situation, because most of the time we will find that we should not go for the fine tuning, right? Because fine tuning is again a static kind of data, because you prepare a data, you fine tune the model, and now you don't need that your data is not going to frequently going to change, so you can just stick to it. But if you are going to be in a situation where your data is frequently going to be changed, then definitely you are not going for a fine tuning, rather you will be going for the RAG. Okay, so what are the scenarios where you should not be relying on the fine tuning, rather rely on the RAG or the prompt engineering of both? When the required knowledge changes very frequently, as I mentioned, that if your knowledge is keep changing, then it means that you have to follow the entire flow, where you have to prepare the data, you have to choose the model, then you have to pre-process the data. So it's very time consuming. So if you know your knowledge base is always going to be changed, then the RAG is the best option. Then when you don't have a sufficient large and high quality data set, that is really important, because if you don't have a good amount of data to train your pre-trained large language model, you are not going to get the accuracy which you are looking for, right? When the base model performs well enough with a simple prompt of the RAG. So first, because fine tuning is the last resort, right? Because it's very complicated as compared to the RAG and the prompt. So if you feel that your large language model is good enough, if you just tweak your prompt, right? If you just make your RAG system, RAG powered AI, RAG system, RAG database is so strong, which I have covered in my another tutorial series. It's a very comprehensive tutorial series where I have a more than 27 parts. If you are really interested to understand a RAG in a more detail, you can watch that, and you can find the link in a description for that tutorial series on the right top screen as well. So if your base model, so this is the first thing which you have to try. Whatever the use case you are trying to solve, you have to see if you just have a combination of prompt engineering and the RAG. If you combine both, if you can get that accuracy which you are looking for, then you should not go for the fine tuning, because it's going to have an overhead for you. When the task is extremely broad and requires a reasoning across many unrelated domains, so again, if your large language model, your use case is actually hitting a multiple domains, right? And those domains are not related, then I won't go for this fine tuning, right? As I mentioned, it has to be a very specific one domain. If the primary goal is to access the up-to-date public information, again, we know that in this situation, RAG is the best option to do that, because we need a up-to-date information, because it's most of the time, because it's just falling into the frequently changed knowledge as well, right? So now we need to just understand the difference between the fine tuning, RAG, and the prompt, because these are the three terminology which I have been using a lot. And I'm saying that once your prompt engineering and the RAG, if these two approaches are not able to solve your problem with the large language model, then you should go for the fine tuning. So if you just see, these are the 6 categories on which I just try to put together a differences, like method, data, flexibility, latency, use case, and the cost, right? So method, so basically, as I mentioned on our very first slide, that we are actually going to modify the weights based on which a large language model actually predict and just create the response for your request. What is RAG? RAG actually inject the context during by the retrieval. So what happens is, for RAG, we have a knowledge base, and then we just extract the data based on the query which user is going to ask to the large language model. And whatever the knowledge base we have, we just create the context based on the query. We attach that to the query, and then we create a very contextualized prompt which we send to the LLM, right? The prompt engineering, in prompt engineering, it's completely depend upon a user who wants to ask anything. He has to define the proper context. If he wants to just provide some kind of example, like, okay, this, if I request this, this is the response I'm expecting. If he can provide the context along with some request response, and then actually ask the question, then prompt engineering gives very accurate answer as well. right? So data. So for fine tuning, we need a label data for training, right? But in RAG, we just need a knowledge base or the document corpus, which I have covered in my tutorial series. You can just watch that and you can get the difference, because in fine tuning, as I mentioned, we are going to use a supervised learning where we have to have a labeled data. In prompt engineering, we don't need any data. It's just that we need an intelligence way to just design our prompt. Flexibility, fine tuning is less flexible. We can understand that. RAG is more dynamic, right? But prompt engineering is definitely highly flexible because it's completely depend upon what you ask to the large language model. Whereas RAG is having more dynamic as compared to the fine tuning, because that is completely hard coded knowledge, because you cannot just fine tune again and again, right? RAG is something where you can keep changing your knowledge, but prompt is definitely the highly flexible. Latency low at runtime, fine tuning, because it just once you just fine tune that, then it's going to just behave the same way the large language model is behaving, right? But RAG is definitely going to be a little bit higher because you have to create a context, by just pulling the information from the knowledge base. And prompt is again, it's going to be very low because it's pretty much same like hitting the large language model without any extra link. Use case, repeated task, control output, as we have already discussed about that. Dynamic task, frequent update needed, understandable, and rapid prototyping and all this stuff, right? So cost is definitely, fine tuning is going to be very costly affair. RAG is less than fine tuning, but still you have to manage the ongoing knowledge base. So it is very debatable, which is going to be more costly, right? Definitely fine tuning is, because we have to have a lot of resources and a very complicated process. We need a dedicated person for that. RAG seems to be a little cheaper, but prompt is definitely going to be the most cheaper option, right? So here are the few scenarios in which you should consider a RAG, prompt, or both, but not the fine tuning, just so that you can understand, right? Fine tuning plus RAG, a medical chatbot could be fine tuned on historical patient data and retrieve real-time research paper for diagnosis, right? Which is very understandable, right? So whatever historical patient data we have, we can just fine tune that, right? And once we have a fine tuned model, that with that, if we just put our knowledge base and then we use a knowledge base plus fine tuned model, right, with the latest and the greatest information, which is depending upon the latest research which is happening or the new diagnoses which are being discovered, then that process like fine tuning with RAG is going to be most helpful for us. Prompt engineering plus RAG, a customer support tool might use prompt to structure a queries while pulling our FAQs from the knowledge, so which is quite understandable. So the key takeaways from this explanation so far: for fine tuning, when we are going to do best for the specialized static task with the sufficient labeled data. So we have to keep in mind, we have to have enough data with the label, because we are going to use a supervised learning to fine tune the already trained large language model, right? It is ideal for the dynamic, and the real time information where the change, where the data is frequently changed, and we always need to consider the latest and the greatest data. Prompt engineering, it's very optimal for the quick and a low cost adjustment if we are not looking for so much accuracy or a very specific or consistent output, and we can adjust, with whatever the large language model is responding. All we can do is we can rely on the prompt engineering, where we can design our prompt as intelligently as possible, provide as much as context we can along with the instruction with request and response, so that prompt engineering can also help us to get the accurate information from the large language model. So that's the last concept which I want to understand from the functional aspect. I hope you really enjoy this. In the next video, we are going to cover the core concept which you have to understand, because there are a lot of configuration during the coding we have to manage by ourselves. So that's it from my side for this video. If you really like this video and if you enjoy this video, give a thumbs up and don't forget to hit the notification bell, so that whenever the next one will be published, you will be notified for the same. If you feel this video can help your friends, colleagues, and groups, please feel free to share with them. And thanks for watching this. And as always, stay healthy and keep learning new things.